Hey, in this video I wanted to go over some ways that we can work with hexadecimal numbers in C++. So hexadecimal numbers are a special format for representing numbers, a different number system that is base 16, whereas our normal is base 10. So hex is base 16, decimal is base 10. That means when you count in decimal, you go, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So you have 10 different values for a single digit, and then once you exhaust all of those values, counting up, you have to use 2 digits. For hexadecimal, you have 16 different values for a single digit. And since we don't really have that in our typography, we have to add in some extra characters. So we use some letters, and then we get to 10. So 16 different values for one digit, and you add one more, and then you get to 10. So what's weird here is that when you write 10 in hexadecimal, it actually is, it looks like 10, it's not really 10. It's actually 16, because we went from 0 to 16 counting through all of these digits. So it's weird to write it out like this, and so in C++, we can make it a little clearer. Like here's a decimal value. So we write it as normal, like 16. And then this is a hex literal. Hex literals are prefixed with 0x, and then you can write your hex value. So these should be exactly the same, 16, and that should evaluate to 16 as well. So you may have seen hex values already when you print out memory addresses. So if I had a pointer to an integer, right? If we printed that out, let's see, memory address, you may have noticed that it prints it out in hexadecimal form, that it has letters and stuff mixed in there. So understanding hexadecimal helps us to understand what these numbers actually are. The best part about hexadecimal is that it's a little more compact than decimal, so you can store larger values in fewer characters printed out like this. So when you're working with memory addresses that get really big, you can still represent them with a smaller number of digits. You may have also seen hex values in hex coloring on the web. You might see red, green, blue values listed, something like whatever, like this. So this one I put in actually 4 colors, 4 color channels. So let me say okay, I don't know what's a good a good data type for this. Let me think about the size of this thing. So the cool thing about hexadecimal is that when you look at 2 of these digits together, the maximum value that 2 digits can get is FF, and that's going to be 255. 256 is how many values can be stored in a single byte. So every pair of every pair of digits represents 1 byte. So this is 4 bytes. So it looks like I chose the right data type. An integer is 4 bytes of storage. So this will fit neatly right into that. And remember, it's just an integer. Like Visual Studio tells you what it is, but it's much harder to interpret 4,200,000,000 whatever as a color. Instead, we treat each of these pairs as a color channel. So maybe FF, this is the maximum value, might be for the red channel, and for like a pixel or something in an art program. And so FF would be fully red, completely red, the maximum value of red. A6 is kind of a high value of green here, the next channel. BB is slightly higher than A6. It's what is that? That's 6. That's so sort of like 12, around there more. Probably like 18. Anyway, these two digits can represent the blue channel, and so and maybe these last ones, these can represent alpha, and alpha is a measure of opacity, whether it's transparent or not. So low values are transparent, high values are opaque. So I would describe this color just by looking at it. It's very red, and it is a little more blue than it is green. So I'd say that it's kind of like a light red, so like a pink that has a little bit of blue in it. So it would look very light pink, but perhaps you'd be able to detect some purplish color in there. And it would be fully transparent. So if a program was actually rendering it with the transparency, you wouldn't see it at all. It'd be clear. All right, so that's pretty common, but much easier than trying to interpret a decimal number as a color. When we are trying to print these things out, you may have noticed when I printed them, they both got evaluated and printed as decimal form. But you can tell cout using what's called a stream manipulator. You can tell it to treat integers as hexadecimal. So after I insert this stream manipulator into the stream here, then numbers that I put here, whether they be decimal, so like this is 32 in decimal, or whether they are in hexadecimal. So the equivalent of 32 should be like that. They should print out as hex. Okay, yep, both of them are looking like the hex form, 20 instead of 32. All right, but they're both the same value. They're both actually decimal 32. All right, and then once you insert that manipulator into the stream, it actually changes the stream, so you're going to have to revert back to decimal in order to get the values you expect. So it would be pretty bad if you were like, okay, let me print out 16, or you can tell pretty easily if you do 15. All right, let me print that out. I want it to say 15, but it's actually saying F. So F is 15. So you're going to have to change the stream again back to decimal, and then you can print out your 15. There we go. Looks good. A cool property of hexadecimal is that it happens to be a base that is a power of 2. So it has a close relationship to the binary base 2 system. And so in binary, if you were talking about powers of 2, here's 1, which is, let's see, 1 is 2 to the 0th power. And if you wanted the next one, there's 2, which is 2 to the 1st power. And if you wanted the next one, there's 4, which is 2 squared, and so on. This is fairly straightforward in binary. You just move the digit over, like left shifting. In hex, there's also a pattern. So OX, let's say 1. Actually, let's go. So 2 is going to be the first power of 2. Or, well, 1 will be the first power of 2, if I'm going with the same pattern here. 2. And we keep going. 4. 8. So kind of seems like our normal decimal system, but that's because we haven't gotten to 16 yet, or we haven't gotten over 10 yet. So once we get to 16, remember 16 is 1 0 in hex, so this is 2 to the 4th. This is 2 to the 5th, and you can keep going and you'll start to see a pattern. So very similar to how there's a pattern for binary, there's a pattern for hexadecimal when you start going into higher powers of 2. Whereas in just decimal form, our normal numbers, it's really hard to tell if a number is a power of 2. It's 512 a power of 2? Is 964 a power of 2? It's really hard to just figure it out if you don't already know. So it's handy in hexadecimal, if we wrote this way, you can identify it immediately just by the way it's written. Okay, and the last thing is that hexadecimal is, because each of those 2 digits next to each other can represent a single byte, this works really well for computer memory, the way that files are stored. And there are special programs called hex editors. Here's one of them. HXD is what I'm using. And you can open up any file. I'm going to open up just, well, how about the program that I just made, hexadecimal.exe. So you see 2 different representations of this. You have the hexadecimal values over here in these columns, 00 to 0F, and then decoded text. This column has the same thing but represented as characters, so trying to interpret it using the ASCII code. So most of this looks like garbage, but you can see some words in here that are actually meant to be read as words, and then you can see their corresponding memory values or integer values over on the side. You see the offsets. These are memory offsets or memory addresses from the beginning of the file to the end, and you can find stuff in here. Oops, let me find hex literal. There we go. So I've found my text that I wrote in here. This was plain text in my program. This is a hex literal, and I can even edit this. This is my awesomeness. I can save it. You'll notice it uses overwrite mode. It does not default to inserting and moving these things because the memory addresses need to stay where they are or the program won't be able to find the right places. It's kind of assuming that you're not going to go in here and screw everything up. But you can change things in place and it won't ruin anything for your programs, for simple programs. So let me try, yeah, I made it so it won't compile. So let me just run this. Where is it? It won't let me. Hold on. Let me make sure it builds. Okay. Okay, save it and try that again. Alright, yeah. So Visual Studio didn't rebuild it. It thought that it was the same program, but it had actually been edited outside of Visual Studio. And I snuck that in there. It's pretty cool. So yeah, they used to be hex editors used to be a tool for hacking certain games. They're still useful for that, but they can also be a really good debugging tool, or help you to figure out what kind of how to kind of handle certain types of files if you're trying to write a loader for a file format, especially a binary file format. Okay, so lots of cool stuff with hexadecimal, and these basic applications go really far. They can enable you to do a lot of good programming and coding work with hexadecimal. I will see you in the next video.